Hello, everyone. Welcome to ArgoCon. This is the first talk of the day. Today, we're going to talk about how you can supercharge your Canary deployments with Step plugins. But first things first, my name is Alexandre Gaudreault. I'm from Quebec. I'm a staff software engineer at Intuit and also an Argo CD maintainers. And with me is my teammate, Zach.
I'm Zach Aller. I'm a staff software engineer at Intuit as well, and the lead maintainer for Argo Rollouts.
So as you can see, we're both working at Intuit and are open source maintainers. So if you haven't heard about Intuit, Intuit is a global fintech company behind various brands such as TurboTax, Credit Karma, QuickBooks, and MailChimp. Intuit is also, as you heard in the keynote, the company that took the decision to open source Argo CD a few years ago, and is constantly involved in the open source and cloud native ecosystem. But today we're going to talk about Argo Rollouts and a major feature that came out in version 1.8, the Canary Step plugins. We'll go over the different use cases that prompted us to implement the feature. Then we'll go over the configuration you need to be able to use it, and you already have some spoilers here. And then I'll do a deep dive into how it's implemented, how to configure it, and we'll have a live demo. Hopefully it goes well, and then we'll finish that with some quick tips on how you can get started and write your own plugins. So on that note, I'll give now the floor to Zach.
So let's start off a little bit with some quick stats about how Intuit uses Argo Rollouts. So at Intuit, we have 24,000 rollout resources with a combined 85,000 steps. We do about 116,000 different deployments a month, and we save an incident roughly 100 plus times a month as well, due to rollouts aborting a particular change. Let's get into why we're all here, though. Plugins. So before Argo Rollouts 1.8, Argo Rollout supported a couple different kinds of plugins, and it's kind of been on a little bit of a plugin journey. We had traffic routers and metric providers. Traffic routers, for those that aren't familiar, is what Rollouts uses to essentially direct traffic, whether it's Istio and ALB, etc. And metrics providers are a provider that Rollouts uses for the source of truth for metrics to determine whether or not it needs to abort. And now, thanks to Alex, who's implemented the Step plugin feature, we have Step plugins. These plugins are a really great addition to the ecosystem because they allow you to essentially adopt rollouts, even if you have a plugin, a traffic router that's not supported currently. You can write your own plugin to do it, and you don't have to contribute that to the open source. The other nice benefit about it is maintaining these plugins is an extremely complex task. And so from the open source side, being able to distribute that workload to you guys all that can become maintainers of various traffic router plugins is a great benefit to the open source project. So what exactly is a plugin? So in Argo Rollouts' view, a plugin is a standalone Go process that runs the gRPC server. We happen to use HashiCorp's Go plugin library, and we use that in Golang's NetRPC mode. We kind of made a trade-off there between using gRPC and NetRPC. We went the NetRPC route because of its simplicity. Essentially, you don't got to deal with proto files, code generation, all the stuff that's involved when you have to deal with gRPC. With the downside is that by choosing NetRPC, plugins have to be written in Go. But all you have to do is implement a simple interface, which you'll see later as well. So the existing steps today. So today, Argo Rollouts has supported pause. It's pretty self-explanatory. Basically, pause is your rollout. We have set wait for traffic distribution, experiments for doing parallel tests, inline analysis runs for, you can have a step that queries your metric provider to determine whether or not to abort the rollout. We also have set canary scale, which lets you adjust your replica count separate from your traffic router. And the last two later additions are set header route and set mirror route. Those are pretty explanatory. You can direct a certain bit of traffic with a particular header to the Canary side, or you can mirror all traffic to the Canary. So why step plugins? The existing plugins, minus those last two, genuinely served a very specific purpose. That was just to send a particular set of traffic to the Canary. Argo Rollouts has an analysis step that people have technically used as sort of a plugin system today, because analysis can spin up jobs. So they'll put an analysis step in there and spin up a job to do a task. That makes things really complicated. It's kind of a misuse of the system, and it creates overhead for the implementers of when people do that. You could argue that so that's what some people do. One of the use cases that I think is extremely important, though, is because we have traffic router plugins now, a lot of times there's a very particular step that particular traffic router has as a feature set, and you might need to implement a custom step to do that, such as routing traffic to a different region before performing your rollout, and then shifting traffic back to the region in steps. I think that's one of the actual main use cases that I see for traffic for step plugins. Then there's just so much more. Like, I can't wait to see what you all create to essentially, the sky's the limit on what you can do. So, so here we have it. This is hopefully the final view of what Argo Rollouts will support for steps, with plugins picking up the brunt of the workload of what you guys plan on creating and doing with them. So I'll pass it over to Alex, and he'll get into exactly how you can configure these and what that looks like.
All right, thank you, Zach. So as Zach said, there was already the metric providers and the traffic provider plugin system that existed. So we reuse the mechanism that were in place to configure these plugins to add now the step plugins configuration. So you can see in the Argo Rollout config map the configs that are required to configure your plugin. Obviously, you'll need to give your plugins a name. That's you that decide what the name of the plugin is. You'll give a location of where that binary is, and then some arguments that you need to execute the binary. And one feature that's specific right now to the step plugin is the disable feature. So we'll come back later on how the disable plugin can affect your rollout, so keep that in mind. So once the plugin has been configured in the controller, now it's time to configure your rollouts objects. To do that, we'll need to use the normal Canary steps. You can see the new steps, the plugin step, and inside that step, we need to provide a name, and the name must match what has been configured in the rollout controller. Then there's also a config object. So the config is not a typed object. You can really put any kind of values in there. It's not just a map of string. It can be any kind of object. So on the second plugin, you have an example with an array. On the first one, you just have a key value. And that's it. That's all the config you need to basically configure your rollouts objects. But the most time-consuming part is actually implementing your binary and implementing the interface. So the first thing is there's three really important methods. There's the run, the terminate, and the abort method. So I'll go into details over each method and how they're executed. But all of these methods, they receive in parameters the rollout object that is being reconciled. And then they also receive a step context. So the step context object is there, and the step context will contain that config object that I've just talked about. And then they return a step result. In the step result, it will contain a phase, and there are 4 phases that your step plugin can return. There's the running, the successful, the failed, and the error phase. And that's it. That's all you need to know to be able to implement a step plugin. So now let's dive into how rollout works and how it will call these methods. So let's assume a simple use case there, that we have a plugin that calls Jenkins, because most people know what Jenkins is. So we're just going to call Jenkins and try to get the result of a job. And we want to have the last result of that job. So what will happen? So your rollout will reconcile, and then we'll go through the different steps, and then eventually it will reach a step that is your plugin. Now, the rollout controller will call the run function over RPC, and the first thing that your plugin will need to do is to parse that config object. So you can imagine that the config object, you will need the domain or the URL of your Jenkins instance, then probably a config to indicate what's the job that you want to query. So you'll need to have these arguments, and your plugin has the type of that object, so it needs to validate that type and make sure that the user provided the right input. Then it calls your business logic. So in this use case, it's going to call your Jenkins instance. Let's say it gets a 200 status code. Your last build was successful. So the plugin will return the successful phase to the rollout controller, and the rollout controller will progress to the next step. So that's a very simple use case, but sometimes things are more complicated. So instead of getting the last job result, let's say we want to trigger a job and wait for that job to complete and then get the result. So instead, we want to run asynchronously. So the difference here is that our plugin, when it calls Jenkins to create that job, it won't return successful because it doesn't know the status yet. And you don't want to hold the line because it's over RPC. So it's going to block the reconciliation if you don't return. So you don't want to wait for the Jenkins job to complete. It can take several minutes. So instead, you will return the running phase to the rollout controller. And with that, you can also return a backoff. So you can say, let's wait for 20 seconds. And then the rollout controller will back off for 20 seconds. But let's say you created the job. Now, you need to get that job on the next execution. So you need to save that job ID somewhere. So in the object status, and I forgot to say, this on the right, it's the status that will be saved into the rollout resource. So in that status, you can also return a state, and that state can be anything that your plugin wants. In this case, you will need to save the job ID, and this state will be passed on your next execution. So you can reuse that ID then to get the correct jobs. So in this case, we call our plugin. We created a job in Jenkins. Now we need to back off 20 seconds, and we need to wait for jobs to complete. So we're going to wait. So after 20 seconds, it's still running, and then we wait another 20 seconds and another 20 seconds. Are we good, Zach? We're good? All right. And then eventually, our plugin will complete, and it will return the successful phase. You can see here that the plugin, the run method, was executed 6 times. So we waited multiple batch of 20 seconds before our job eventually completed. And our job completed successfully. But Jenkins jobs do not always work. Sometimes they fail. What happens if our job had failed? So in the case of execution failure, pretty simple. Your plugin will return the failed state. Now, what happens when you return the failed state? Instead of progressing to the next step, it will abort the rollout. So that's pretty important, because a rollout that is aborted will roll back. Basically, it will cancel the promotion to the new version and will roll back to the currently stable version. So there's a note at the bottom. It is very different than returning an error. If you return an error, it's because something happened that's not handled. So, the rollout controller will retry on errors. It won't abort the rollout. All right? So what happens when a rollout is aborted? Obviously, that's not only because a step plugin may have failed. It can be because it was manually aborted. It can be because the progress deadline expired, or any other reason. So the rollout aborts. We will go through the steps, and what's special about a step plugin is that we're going to start calling the abort method that's defined on the plugin interface in the reverse order of the plugins that were executed. So you can see here, index 4, index 2, this is the index of your step sequence. So we can see that it called the executed plugin in the reverse order. So let's say we trigger a job in Jenkins, and that job is running, and someone manually aborts the rollout. That gives a chance to cancel that job because it's not needed anymore. And the third method, the terminate method, is called similarly to the abort method, but when someone wants to fully promote a rollout. So that means the user, maybe the rollout is in the middle of the steps. The user say, hey, I want this deployed immediately, so skip all the steps. If there's an ongoing step plugin that's running, it will call the terminate method. So again, it gives the chance to the plugin to cancel any ongoing operation. And finally, the disable use case that I talked about earlier. So let's say Jenkins is down. It happens. Maybe the Jenkins team, they're doing a maintenance, so your endpoint is not available. What would happen if the endpoint is not available? The plugin will return error, and no rollouts in your company would be able to progress to the next step. Potentially, at some point, they hit a deadline, and they all abort. So we don't want that. So as a way to mitigate that, a rollout operator can go in the config map, disable the plugin, and in your execution, the rollout will simply skip that plugin and progress to the next step. And that's it. So pretty much everything I've just said is resumed in this flowchart, but it's a bit complicated, and it was complicated to write. So instead, I think it's time to see it in action.
So let's take a look at a live demo and see how this all works and pans out. Let me switch. Yeah, so there's a lot on this screen, so I'm going to kind of start off with just kind of orienting and setting up the demo. The idea of the demo is that we have a rollout defined here on the, where's my mouse not working? On the right side, and it has some plugin steps in it. I won't go up to the top here. So the very first plugin step will essentially shift 100% of the traffic over to the secondary region so that we can continue doing the rollout in the primary region. And then once the rollout in the primary region is done, we will start slowly shifting traffic back over to the primary. This is all contrived. This is a fake CRD. So up in the top left over here, I have basically a CRD that represents where traffic is flowing. And we can see that 100% of the traffic is going towards the primary region. So as I trigger a rollout, give it just a second. We'll come down over in the rollout object. It's here, and look at the statuses. We can already see right away that we have the first status here. And as Alex was saying, the status inside this block is data that's returned from the plugin. This is the area where you get to store your state that you need for your plugin. All this top stuff is the what rollouts use to determine whether plugin's still running, etc. This plugin is currently waiting for a pause. So we see right now we just triggered our second execution. So your run method has to be idempotent. It needs to be able to be called multiple times, essentially is what that means. And so we just shifted 100% of our traffic to the secondary. We can see that we have another step now that's been executed down here on index 3. We are also waiting for it to stabilize. And we store the original region's reference because we'll see how that gets used later when we go ahead and abort this rollout. So I'll just let this one finish. Jeopardy music playing.
5 minutes left.
Okay, so we see that we're now shifted 60% to the primary, 40% to the secondary, and we have our 5th step. Let's just say we need to abort. And we can come over here and look at the status and see that we've essentially gone through index 5, index 3, and index 0 in reverse order. And we've shifted the traffic essentially back to the primary. This was contrived example. The real mode you'd probably want is to keep the traffic back over in the secondary since something was wrong in primary, but it just demonstrates the calling of the steps in reverse order. So that's the demo. It went well. Thank you, demo gods.
When it's fully offline, it goes well.
So let me shift back over here. So how do you write these plugins? Well, you implement the interface, right? You build a binary, you write some documentation. Hopefully you publish it to Argo Proj Labs so that it can be an open source plugin. Or you do what I do, and I actually created this whole entire demo using AI in about 3 prompts because the interface is so easy to implement. And it got it right away. The first prompt had a working thing, added 2 new prompts for some features, and that was the demo. However, probably not production worthy, so I'll pass it off to Alex so that he can tell you the best practices.
Yeah, so there's some things that your AI won't know, so sometimes it's good to feed it some context. I'll do that super quick so we can have time for questions. So first of all, as I said, long-running operation, this is running over RPC, so even if your call takes 10 seconds, you're blocking the reconciliation of a rollout of a Go routine for 10 seconds. So always prefer to run asynchronously. So when you run asynchronously, save a state in the rollout status. Because don't save a state in memory, because if the rollouts crash or gets restarted, things that happens on Kubernetes, that state will be lost. That's why we offer a way to persist that state in the rollout CR. Then be careful, don't put a huge state in that rollout CR because Kubernetes object, they have a size limit, and this state is persisted for each plugins. So the status of the rollout CR can grow really big if you're not careful with your status. And finally, now we're giving you an opportunity to create your own little API in Argo Rollouts. So you're the people that implements plugin. You're the people that define what the config object should be. And this is given to the users so they can configure their rollout object. So be careful of what you put as config objects. And so that's pretty much it. So I think we have some times for question. Thanks for listening. And if you have more questions after this talk, we'll be at the Intuit booth during ArgoCon. We'll be at KubeCon booth as well, at the maintainers booth on the open source project. And we'll be happy to answer any of your questions or use cases that you might have. So thank you. Questions? Anyone? There's 2 mic. There's 1 mic. Can you walk to the mic, please? Try to speak louder. No, it doesn't work.
Thank you guys for a nice presentation. Quick question is about secrets. Like if my plugin needs some credentials or something to connect to Jenkins, as your example, how you will provide it?
Yeah. So your plugin basically runs as a binary within the rollout controller. So your plugin has access to the same thing the controller has access. So if you create a secret in the controller namespace, because in general, I think the Argo controller can get secret, you'll be able to get that Kubernetes secret from your plugin.
And in your step plugin, you'd probably just want to give like the secret reference. So whether it's the name of the secret or if it's a cross namespace call, you would just reference that in your plugin as well.
If
you need that.
If it needs to be configured by the user, if
Yeah.
it's just for your plugin to work,
Then-
that's probably a setting as an argument in the Argo rollout config map.
Yep.
Thank you for clarification.
All right. Anyone else? Anyone happy about this feature other than me? Yes, I love this. All right, so thank you, everyone.